Each year, foodborne pathogens cause numerous illnesses and deaths. One particular group of bacterial pathogens causing concern is the Shiga Toxin-Producing E. coli, or STEC. These organisms cause flu-like symptoms that can range from mild to life-threatening. Serious complications include hemolytic uremic syndrome, which can result in kidney failure and death. While STEC can be found in a number of foodborne sources, the USDA has declared 7 serotypes adulterants when found in raw, non-intact beef. Beef processors have implemented food safety and processing controls in order to reduce the risk of STEC in their products. In particular, control measures have been taken for ground beef and non-intact beef production. These products require grinding, cubing, or other tenderization methods which break the surface of the meat and can redistribute STEC within the product. One control measure that can be used is the spray application of organic acids to beef primals and subprimals to reduce the risk of STEC in the finished product. There has been considerable research on the use and effectiveness of organic acids to reduce the risk of STEC in ground and non-intact beef products. This video is targeted at small business beef processors who often are challenged to find supporting documents matching the resources of their operations. For this reason, research by the University of Nebraska-Lincoln has been focused on identifying application and organic acid options that can be used in small operations. This video specifically addresses the application of a lactic acid solution by handheld spraying method to beef subprimals. Other organic acids and appropriate supporting documentation for application can be used for the reduction of STEC. It is very important that the critical parameters used by the operation match those in the supporting documentation. Some common examples of critical parameters include time of application, temperature of the solution, application method, concentration of the solution, and the type of acid used. Other critical parameters that may be identified in a scientific document are amount of solution applied, product surface temperature, and surface area of product to be treated. There are some general safety precautions that must be taken when working with any organic acids. First, be sure to review the safety data sheet for the specific product you are using. This can be obtained from the organic acid supplier or manufacturer and may be available on their website. The safety data sheet includes the specific personal protective equipment that should be worn when working with the acid, any hazards associated with the product, including reactive substances, and any special storage needs. It is also important to read the label on the product and make sure it is appropriate for food use or application method. General personal protective equipment that may be needed include a frock or apron, chemical-resistant gloves, and goggles or a face shield. Additionally, plant-required safety equipment such as a hard hat and steel-toed boots should be worn. Be sure all items are clean and in good repair. Follow all plant good manufacturing practices, including hairnet use and hand washing procedures before beginning. Because we are working with acid, it is important that equipment and supplies be made of corrosion-resistant materials, such as some food-grade plastics and stainless steel. For the spray application of lactic acid, you will need the following. For the purposes of this video, we will be using 88% lactic acid concentrate. A graduated cylinder will be needed for accurate measurement of the lactic acid concentrate. A food-grade container will be needed that is large enough to accommodate the amount of solution that will be mixed. You will need access to water of 70 to 75 degrees Fahrenheit. To ensure the correct amount of water is used, we will be weighing it, so you need a scale capable of weighing the necessary amount. 1 gallon of water weighs 8.34 pounds at 70 degrees Fahrenheit. The weight of a gallon of water will vary slightly with water temperature outside of the range previously indicated. A calibrated thermometer will be used to measure the temperature of the water. The dilution chart for this product shows the amount of 88% lactic acid needed to reach the desired concentration in both ounces and milliliters. For the purpose of this video, we will use a graduated cylinder to measure milliliters. A spoon, paddle, or other stirring device will be needed for mixing the lactic acid solution. It should be long enough to reach the bottom of the container. A titration kit can be purchased from your acid supplier or manufacturer. This will allow you to verify the concentration of your solution before application. This kit includes instructions for completing the test as well as a titration chart for interpreting the results. You will need a stainless steel sprayer sized appropriately for your application and with the ability to be pressurized. Here we are using a 2-gallon sprayer. The spray gun used for this procedure should be stainless steel on the interior portions, which will come in contact with the lactic acid solution. A fan-shaped spray nozzle will be used to evenly distribute the lactic acid solution on the beef subprimal surface. It is very important to keep the spray nozzle clean, away from sources of cross-contamination, and off the floor. We will be using a 30-degree fan-shaped spray nozzle that will deliver 0.3 gallons of solution per minute at 20 psi. To operate our sprayer, constant air pressure is needed to ensure consistent application of lactic acid. This can be done with an in-house air line or by using a small air compressor. We have found an in-house air line to more consistently deliver the needed pressure. The air line will need to have a regulator so the pressure can be held throughout the application. We will be working with 20 psi. Finally, a clean workstation is needed that allows excess lactic acid to drain from the subprimals. This can either be a table that allows drainage or can be accomplished with elevated food-grade racks over the tabletop, as you will see later in this video. The lactic acid solution should be mixed as close to the time of use as possible. Before adding water to the mixing vessel, it is important to make sure it has reached the proper temperature. Allow the water to run for several seconds before adding water to the bucket or tub. The water will be weighed to ensure the accuracy of dilution. Place the bucket or tub used for mixing on the scale and tare it. Begin adding water until the desired weight is reached. We will be making 1 gallon of solution today and need 8.34 pounds of water. It is important to note you will need to pause while adding water to allow the scale to settle on a weight to be sure you have enough water. Once the appropriate amount of water is in the container, use a calibrated thermometer to make sure the water temperature is between 70 and 75 degrees Fahrenheit. We will use a clean container to reserve a small amount of water for rinsing the graduated cylinder after measuring lactic acid. We are targeting a 4.5% lactic acid solution. As you can see on the dilution chart, that requires 194 milliliters of 88% lactic acid concentrate per gallon of water. Very carefully measure out the necessary amount of 88% lactic acid concentrate into the graduated cylinder. Accuracy is important to ensure the correct concentration of the lactic acid solution. Because we are making 1 gallon of solution, we will use a total of 194 milliliters of 88% lactic acid concentrate. This is specific to the lactic acid we are using, so be sure to consult the dilution chart for your acid. The lactic acid can now be added to the water. Adding water to the acid could cause the concentrated lactic acid to splash and cause injury or damage. Use the reserved water from earlier to rinse the graduated cylinder. The concentrated lactic acid is thick and may not pour completely, so rinsing is important to ensure all measured lactic acid is added to the solution. Add any remaining reserved water to the mixing vessel. Carefully stir the solution. Be sure to follow the specific instructions that come with your titration kit, as they may vary by organic acid and supplier. It is important to hold the reagent bottles straight up and down to allow uniform drops and prevent air bubbles. Do not touch the tip of the dropper to the test tube and add drops slowly to ensure an accurate result. The regulatory maximum concentration for lactic acid is 5%. We are targeting 4.5% to ensure we meet the concentration identified in our research and do not exceed the maximum regulatory concentration. Adjust the solution with additional water or 88% lactic acid concentrate as needed to reach the desired concentration. The final concentration of the spray solution should be recorded and kept for production records. A document like this example can be used as a running log for several production dates. The solution can be added to the sprayer and the lid secured. Making sure the airflow is off, attach the air line and the spray nozzle to the tank. Turn on the airflow and adjust the regulator on the airline so that it is set to 20 psi. Lay the product to be treated out on a clean, sanitized work surface. Make sure all external surfaces are exposed by checking that the meat is not folded or stacked and there is some space between subprimals. Once the work area has been set up, begin to spray the product. It is important to keep the spray nozzle 10 to 12 inches from the production and cover all surfaces. We are using a 30-degree fan-shaped spray nozzle that will deliver 0.3 gallons per minute at 20 psi. In UNL research, each side of the clod was sprayed for 11 seconds, which applies approximately 208 milliliters per side. The spraying time will vary with the surface area, pressure, and flow rate of the sprayer. Once the work area has been set up, begin to spray the product. It is important to keep the spray nozzle 10 to 12 inches from the product and cover all surfaces. Once one side has been completed, all pieces should be flipped and the spraying procedure repeated. It is important to cover the sides as well as the larger surfaces to ensure complete treatment. After spraying both sides of the product, the pieces should be allowed to drain. It is important that subprimals not sit in a pool of lactic acid and be allowed to drain until all excess or pooling is eliminated from the meat surface. This helps prevent over-application of lactic acid and possible quality defects from overexposure. In our study, draining took approximately 60 seconds. Any remaining mixed lactic acid solution may be stored according to manufacturer's recommendations. However, if storage is allowed, the solution should be titrated prior to each use to ensure it is still at the correct concentration. Proper disposal will be determined by the organic acid used, amount used, and local regulations. All equipment and utensils should be washed thoroughly according to plant sanitation standard operating procedures. Initial rinsing is very important to remove any residual lactic acid and prevent corrosion. This includes running clean water through the line and spray nozzle from the sprayer. Organic acid interventions can be an effective tool against the threat of E. coli 0157 and non-0157 STEC. Their use should be combined with good manufacturing practices and sanitation procedures for the most effective results. This video has outlined a standard procedure that can be used for the spray application of lactic acid to beef subprimals. Specifically, the procedure described can be used by small business beef processors producing ground beef or non-intact beef. A similar process may be used for applying other approved organic acids, provided the critical parameters are adjusted to match the supporting documentation.